Before we really go on to the technical aspects, this is a map of Bhutan, as you can see, and then the watersheds and sub-watersheds, also sub-basin that we have. And I don't know how much our international participants know. We have 4 major basins and sub-basins. We are here in Bhutan, the red one. And I just wanted to highlight that because my subsequent talk, as I mentioned earlier, would be about some things that we're doing in Bhutan. So Bhutan, we are here in Bhutan. Let's know some basics of Bhutan. It's one of the culture centers of the country with 4 gyokes, a lot of farmland, and then also Choko Gyok, which is just by the Jamkhachu, the big river that we see around next to the town, has a history of flooding and a bunch of glaciers upstream. And there have been some couple of floods also, we can see in the pictures down there. And they also have the highest number of high altitude wetlands as found by our friends from US. And 3 of the 24 potentially dangerous lakes in Bhutan identified by ECMOT are also in the headwaters of this particular catchment. And as we discussed yesterday, or rather our speakers pointed out, hydropower is an important source of revenue for Bhutan. We have a big project coming up in the Jamkhachu downstream, few tens of kilometers just downstream of Bhutan. We have tried to look at some of the climate parameters. One thing that we looked at it was on the rainfall. And then 2 years ago, I did a small research with a bunch of students from the US who were studying here at UIS. And we did survey of the local community, more than 100 households, key informant surveys, and found out that it is actually has been observed by the local community that the rainfall has decreased, and with 43%. And then it is also, in fact, visible from the graphs that we see here, both annual total, summer total, and winter total rainfall patterns over the last almost 20 years, that the rainfall trend does show a negative trend. But for the scientists here, statistically speaking, it's not significant. And it has chiefly to do with the fact that the data series is not adequate. And we also try to look at what is the perception on snowfall. Unfortunately, we do not have recorded snowfall information in Bhutan under rainfall. But the winter precipitation is encompassing of the snow water equivalent of rainfall as total precipitation. When we ask people around in the Bhutan Valley, 87% of people mentioned that they have observed decrease in snowfall. So, as I was saying earlier, people's perception matches up with what's actually being shown by our data also. So this shows that the rainfall in the valley is decreasing. And then we try to look at the river flow in Jamkhachu. Just near the Dorji temple, which is about 2 kilometers from town, or maybe 3 or 4, not very far, there is a gauging station. And as we can see here, there is a decreasing trend for the summer and the total. And in the winter, which also includes the spring meltwater, does show a slight positive trend, whereas the total and the summer monsoon flow is showing a negative trend. So this is again contradictory to the rainfall because the rainfall trend, as we saw, was decreasing, whereas the flow here is showing a positive trend. Again, I would highlight the fact that as scientists, we would want to mention the fact that it's statistically not significant, just in case if you're wondering. And now we also try to look at lean season flow. Across the country, what the Department of Hydromet does in the month of January and February, spot lean flow measurements of smaller streams and creeks. And there are 3 such small streams in the Bhutan area, in the Jamkhachu. One is the Chhimi, Urachu, and the Tamchu. And they also show in the winter a decreasing trend. And what we are trying to infer from here is that probably the flow in the spring is due to melting glaciers, increase in melting. And now to take it further, we will go into what we try to look at was some of the glacier studies. And there has been an extensive study done by the International Center for Mountain Development, ICIMOD. Mr. Dorji is here. His colleagues has done a study based on satellite imagery. And this is what we have in Bhutan. 885 glaciers covering some 642 square kilometers, and that is about 1.7% of our total area. And we can see that these blue ones here are the glaciers of Bhutan. And the same study has also done a decadal rate of change in glacier area in numbers. Excuse me. From 1980 to 2010, in about 3 decades, there had been a reduction of 23% in the total glacier area. And at the same time, the glacier number has increased by almost 15%. And this is probably due to fragmentation of big glaciers into smaller glaciers. What we see here is that in the Manas Basin, Chamkrachu, by the way, is a sub-basin of the bigger Manas Basin, as we saw earlier in the water resources, the basin map of Bhutan. In this basin also, the number of glaciers have been increasing and the area has been decreasing. So this sort of goes in line with what we found out from the actual observed data analysis of those information. And what the Department of Hydrometeorology Services has is also an ongoing project up north of Chamkarchu headwaters. This is Pumtang here, and then a small glacier has been identified. This is the Thanagang Glacier. This is the glacier that I'll be talking about now. And then we see that it's an access from here. This is the actual headwaters of the Chamkarchu. And this is a base camp. And then this is Chukdatso, one of the biggest glacial lakes in this area. So within that, the context of the project study, we have also tried to look at parameters and snow information, because as I was mentioning before, we do not have much information on snow at all in the country. And what we found out is that the snow density is about 0.33 kg per meter cube. And the depth we got in that pit is about 72 centimeters. And then we have also done a snow transect on the basin, on the glacier itself. So what we usually do is, on the glaciers, we try to measure what is the depth of the snow. And then what the method is that same method is done, repeated every year on the same transect. So we have the GPS coordinates. The idea is that we will be doing the same thing every year, so that we see that at this time of the year, last year, this was the thickness, the following year, this is the thickness, so that we see the actual change in snow cover on the glaciers also. And then the graphs shows the depth of snow along the different transects now. And what we also do is doing mass balance now. Mass balance basically means trying to measure the depth of ice, taking a baseline and trying to see how it changes over the years. So snow is one thing, and then also measuring the ice itself. And our colleague from DGM will go into details of those things later, because he has done extensive studies. And ours has been just done for the last 2 years, so we do not have the actual mass balance results. And in addition to the stake measurements, mass balance, the stake measurements, which they are done through having holes like this inside the ice. And we have also measured ice thicknesses and some other climate parameters. An ice thickness study was done by a German collaborating agency with us, using ground penetrating radar in the same profile that we have done the snow survey, snow depth transacts. And what we have found out is that the depth of ice in that area ranges from 70 to 100 meters of ice. So the glacier that I showed earlier, in this area, this is the depth of ice that is there. And as I was mentioning earlier, we are also trying to collect some information about the temperature and relative humidity in that area. We don't have any high altitude, or rather very, very few climate stations and climate information of our high altitudes. That's why this is one of its first of its kind, set up by the Norwegian Water Resources and Energy Institute, Energy Directorate and the Department of Environment Services. We have data for almost 2 years, and then from this we see that, sorry, this should have been going up much now. The maximum temperature we have seen was about 12 degrees Celsius in May to the 2014, and minimum of about 20 degrees Celsius. So this is, as far as we have collected the list, the lowest temperatures that we have been able to measure. And this is obviously at 5,136 meters above the sea level. Different agencies have done is the GLOF mitigation in the Punasangchu headwaters. And so these are the famous lakes of the Lunana lakes, as our colleague from JDNP, the Park, also showed in his picture presentation yesterday. The lakes up there, Vichun Glacier, Rapsing Lake, and the Tortoni. So what the study found out, this is unique. Maybe this needs some attention. And then they have zoomed in, and this is what they found, that there is a moraine barrier between the two lakes, and the width is only about 32 meters in some of the areas. And then the two lakes are at a level of, I'm sorry, you might not be able to see it, but I'll read it out, about 79 meters of height difference. So the hydrostatic pressure, if this lake's built up to this already formed glacier lake, is pretty substantial. And the risk is that it will overtop it, and then it's estimated that 53 million cubic meters of water would flood down the valley. And this will be a very, very huge. And now that study has been done, and then a subsequent project has followed up, where the risk was mitigated through lowering the lake by 5 meters, done between 2008 to 2013. I think they actually eventually ended up finishing 2031. Yes. And so it was a GEF LDCF funding with lots of, as our honorable speakers are mentioning, with actual muscle powers, no machines or. And then the second component was trying to have a GLOF early warning system. GLOF, by the way, is Glacier Lake outburst flood, and early warning systems are used to reduce the disaster risks so that people can be informed. So in the early warning system, what is there is in the lakes, and then also on the outlets of the lakes, and then on the downstream river sides, we have water level sensors and other weather stations, so that the temperature and other climatic conditions are observed real time and then communicated through satellite to a control center in Wangdi, and have siren stations along the valley so that people can be informed and evacuated. This is what we have. So the sensors are way up on the mountains in Lunana, and then we have not so many communities living up there. Immediate to the glaciers, we do have communities of Laya, Keok, but not many in between. And then when we get down to Punakha, Wangdi valleys, lots of people and lots of projects and lives living in the area. But so in case if anything happens up there, the early warning system would be able to give them a heads up, saying that, okay, there is a disaster coming. And then the lead time expected is about 6 hours to something. That's where the major human settlement starts in this basin. And then 7 hours. And then by the time it gets down to the Punasangchu, where we have big mega projects happening in the country, hydropower projects, about 8 hours. So hopefully, man and machinery that are movable could be moved out of the way. Coordinated with advocacy and awareness, basically by the Department of Disaster Management, looking at community-based disaster management, or CBDRM. And so in the Chamkachu also there have been projects, research studies done, and then the subsequent one is, there is a project now started very recently on GLOF and rainstorm flood forecasting and warning by the Department of Hydrometeorology Services. In this project also, there will be hazard flood hazard zonation done for both the Tromsø and the Bhutan valleys. An early warning system would be set up using VHF systems, and then also building up capacity to study those things and manage the systems, and also setting up a community-based early warning system, again CPDR, with proper awareness and taking the community on board. And this is a map of Bhutan. We are somewhere up here. We see that the airport is down there, and according to our hazard assessment, the airport is totally under flood risk. This is a GLOF risk analysis. And now, what? What do you think is this? Exactly, global warming, right? This is just a teaser. And even in Bhutan's context, we do see that the climate is changing. Again, as a technical person, I would not say that it is statistically significant, but the analysis of temperature data that we have observed across the country shows that the change in temperature is all positive. That means that on a year-to-year basis, our temperature is increasing, both for the summer and winter, and then the summer and winter are broken up into different categories. And then, as we would all agree, when the temperature changes, these things are will be suffering. And then also, as I was saying earlier, when we did this project in Bhutan, we also tried to look at what are people's experience, their perceptions. And we have found out that 85% of the survey respondents believe that the climate has changed since they were born. And all of our respondents were more than 20 or 30. And then also, the records for Chankar, which is just next to the town, we see that the trends are positive. Both annual average, summer average, and winter average. Not very good R-squares, but positive trends. And then the data are again from 96 to 2012. So this is just perception of overall temperature in a pie chart. However, we also try to look at gender and education level to see if more educated people have that opinion or less educated people have a different opinion, and then also trying to look at gender. But we could not find conclusive or any substantive association between those categories. But it does suggest that the villagers' perception on climate and what our data is showing are in the same sort of line of thought. And now, to give a chronological of, I should have started this one, but I do have some tips on or ideas on having it at the end. There have been lots of studies, not lot in a sense, but some studies done on glaciers in Bhutan, starting from 1967, Professor Auguste Ganse's first visit to Bhutan. He's a Swiss geologist who studied the glaciers of Bhutan for the first time in the country. And in the 60s and 70s, he said, the 1967 finding, he said that some of the lunar glaciers are risky. And we have seen a couple of major and smaller floodings in the valley after that. But then again, these other studies were continued, as our DG sir from GSI mentioned, 1994 study and 95 studies, and then the multidisciplinary team, and then the lowering of the lake with collaboration of government and the support of the government of India, lowering the upstream lake. And then there were other studies done from until 2008, and after 2008 we had this big project I mentioned earlier through GEF and LDCF funding. At the same time, the study was also done on the Champaju headwaters and came up with different, for a need to have certain things up here. And fortunately, we do have this project going on from 2013-14 to about 2016. And then also, we have done, as I was mentioning earlier, we have done some studies in the Tana Glacier. And then to the follow-up with the Norwegian support. And then follow-up to that one, now we have a big project with International Center for Mountain Development. We will be, the department will be trying to look at the whole cryosphere system over time, and then also looking at certain pilot glaciers and pilot glacier lakes, trying to do the technical and also the socio-economic aspects of it with all the relevant stakeholders and agencies in the country. Now, to conclude, as we would all agree, snowy glaciers are important for mankind, both from tourism or economic, and also, as mentioned earlier, they are part, by Ben yesterday, they are also part of identity of the local people, our associations with the glaciers and snow. And in Bhutan's case, for instance, actually I've done a paper, but it was too much here, I only had half an hour, so I couldn't present it. What we also tried, a paper that I did for the Bhutan Ecological Society was looking at patterns of first snowfall trends in Thimphu. Snowfalls are big events in Bhutan. In the past, we used to have lots of snowfalls. The first snowfall is always holiday, national holiday. And then the people are every winter excited, when will we have the first snowfall? And I've tried to look at the study, and unfortunately this year my study did not come true. My forecast was based on statistical analysis sometime in the middle of January. But we did not have a snowfall this time, in Thimphu at least. Zero, yeah, no snowfall, we did not get a snow holiday. So they are also part of the culture. So I'm assuming that we did not have these things before. But in the last 40, 50 years, this has become part of our culture. It's to have a snow holiday and to be looking forward every winter to snowfall. And of course, it is also associated with many other things such as agriculture. And as we have seen, glaciers are also source of disasters. But if we work in collaboration and do proper studies, we can reduce and manage the risks. And as we have seen in the change in the dressing pattern in the world, climate is changing, and it is definitely going to impact how glaciers behave. And a way forward I see is that we definitely need to have more research and collaboration to avoid, firstly, duplication, even in country or with other universities or research groups, so that we don't end up doing the same thing by different groups. And then also for technology transfer, there are very interesting technologies, remote sensing-based technologies, modeling-based systems that we may or may not know. So it is good to know about those things and exchange our ideas, and then also obviously sharing experiences with each other. But what I would really like to submit to the August gathering here is that research should not be just aimed for, I'll be very blunt here, for publication of papers and understanding the science alone. And I would like to use Christian's words from last night, I'll not be diplomatic here. I'll be very straightforward, I'm a scientist, I'll be very straightforward here, that publishing papers should not be the goal of any project for that matter, whether it's glaciers or snow or hydrology. It's good to have papers in your CVs or in resumes or in research proposals, but if it doesn't benefit the society at large, I don't see a value in it. And the society should definitely benefit from our studies. Simply progressing the science is not enough. As a project director from NASA once told me, NASA has all this latest state-of-the-art satellites and methods and sending men to moon and flying on Mars missions and stuff like that. If it doesn't benefit someone who is living next to us, it's of no use. And as far as I know, that's what NASA is now trying to do with the USAID and other projects, trying to bring this technology and services so that the society can benefit. And my submission, humble request to the August gathering here again, is that let's try to work together, but not just for the sake of getting donor fundings or getting papers published alone. But as we have seen in Bhutan's case, we have done some books and some studies, of course, with the help and support from our donor communities and international collaborations. And you can also see that most of these projects have resulted in practical benefits to the society. And this is what we should, as Ben was also mentioning again yesterday, we should have policies, we should have projects that are actually coming out as results. And we have seen that, for instance, UISS was able to come up with some policy briefs, at least a policy brief that will help the decision makers understand what is happening up on the mountains or in other places, and what and how we can work together so that we can help it. Thank you, and Tashidil.